Welcome to the shop and part 2 of our pulley repair video. In this video I'm going to show you how you can broach an internal keyway using your lathe. So let's step over to the bench and I'll talk about the tooling and its profiles. It's nothing too complicated, and then we'll step over to the lathe and get this keyway cut. Okay, so let's talk about the tools that I'm using to cut this 1/4 inch keyway. All I have is just a 1/4 by 1/4 high-speed steel cutting blank. This is unprofiled, which will be perfect for our application. All you really need to do is just touch up your cutting end, get that nice and sharp, maybe give it a little bit of a polish. Set it in a squared off tool holder, and we're pretty much ready to go. One thing I will say is do not butt this up against the shoulder, as it will cut a little bit on an angle, because this is not, our corners are not a perfect 90-degree angle. So keep it off the shoulder a little bit and we should get a nice square keyway. So let's step over to the lathe and I'll show you how we set this up. Okay, so with our tool holder installed, what we want to do is the best way to do this, well, a better way to set your height of your tool, is what we want to do is we want the center of our tool to be on the center of our part. So I install my spindle adapter with, really any center will work as long as it has a fine point. There is a tool that I made to set tool height, but I'll demonstrate that in a later video. And then, like I said, what we want to do is we just wheel our part up to our center, and we want the center of our cutting tool to be in line with the point of our live center, and you want to check that with the tool post in the clamped position. Don't check it when it's free floating, because it will change when it's not locked down. And as you can see, we are pretty darn close to centered up. Perfectly good enough for what we're working on right now. More than adequate. And then as far as tool setup, obviously you want your relief to the back. I have my compound set to 0 so I can travel nice, and I can utilize the full travel of my compound. And I have my tool post offset by about 3 degrees, so that I can have a little relief on the back side of our cutting tool. So from here, let's go ahead and get our pulley installed, and we'll get to making this keyway. Okay, and then as I stated in the last video, I have my spindle indexed to all my chucks so that I can get repeatability. Whenever you do this, you want to make sure that your spindle nose is wiped down, make sure that your chuck is wiped down and perfectly clean, where that can obviously change your run out. Won't be very accurate. I've seen a single chip cause a whole lot of aggravation, especially when you get in a hurry. You want to lock your headstock up. Make sure that it doesn't move. You don't want it rotating around. as we make our cuts. And from here, this isn't the fastest way to do it by any means, and I'm running about 5/1000ths a pass, and that's all you do is you just run your cross slide back and forth. This works really pretty good on aluminum. You know, if you're working on aluminum pulleys, pretty much anything that you can cut with high-speed steel, you can use this method with. And if you start feeling your tool drag a little bit, you'll just take it out. You might have to touch it up. I don't think we're going to have to really. I don't think that's going to be an issue. Cast cut's pretty good. And then as I get closer to the depth, just like I would when I'm turning apart, I'll back off a little bit on my depth of cut, just because we are going to get some flex in this tool, and we want it to be the same all the way through. So consider those heavier 4 or 5/1000ths cuts your roughing cuts, and then as you work your way to your final depth, you'll back that down a little bit, your depth of cut, just to keep everything equal. And you'll have a very nice 1/4 inch keyway cut. You could also do this with a parting tool, depending on the thickness of the parting tool. You would set it up either just above or just below center, and you would go through this process top and bottom of your center line twice, 1/4 inch. But this really works slick if you're cutting a you know, smaller keyways. 1/4 inch is pretty heavy. And I do want this keyway a little bit heavier, just because of the amount of material it's going to go through. Remember, this key has to go through a bushing and then make contact in the shaft itself. So I'll cut this a little bit deeper than what I need to. That was a little too big of a cut right there. There we go. So just get that squared up. And you could cut a little bit more of a back angle. I'll show you some of these chips. These are the chips that we're making. Pretty good little curls. These are the finer cuts that I've just been doing, the powder. It is entirely possible to get all this stuff done on your lathe. This is how they would have done it back in the day, before they had anything else other than a lathe. Or you could use an old school die filer or something like that. We'll talk about die filers in a later video. Those are fun, especially if you do a lot of precision work. You know, die filers, going off topic just a little bit, they're a tool that was probably in every machine shop, tool and die guy's shop across the land. And were very, very commonplace right up until really the development of EDM. They kind of faded out. I'm going to take a look. Oh, we still got a little ways to go. I want this to be about an 1/8 inch deep, or thereabouts. A little heavier wouldn't bother me too much. But the die filer, I don't know why watchmakers and gunsmiths and jewelry makers these days don't have them. They're an outstanding tool. I guess probably they're just a forgotten tool. I'm just going to get this cleaned up a little bit. Get it evened out, and we'll take a look and see what we got. I think we still have a couple tenths to go. I just want to get this trued up. This is kind of the same idea as boring, in that the more tool you have hanging out of the tool holder, the more we're not really concerned with vibration because nothing's running. But we do have a degree of tool deflection. So really, like with boring, I don't ever, depending on the material I'm cutting, I don't take big heavy cuts because I'll get a lot of tool deflection. It'll have a taper to it. So let's go ahead. What I can do is I can just use that other piece of 1/4 inch to gauge my thickness, and we are pretty true throughout the keyway. I am going to go just a few more 10,000ths, just because this is going to have a lot of mass in there. That's 5. That's 10. $15. 20. 25. 30. 35, I think 40 thou will do it. And we'll take a look. We'll get this trued up, and we'll take a look. This is about the maximum depth keyway that I would want to cut this way. We're probably sitting at about 1.25 inches or so, and that's a pretty significant. I'm just watching the chips come out the back. When I see a really fine powder, as well as very minimal drag on my cross slide, which we're almost there, then we'll check it, and I believe we will be just about done. I think that's probably pretty good. Oh yeah, that's plenty good. So let's now we can remove our pulley from the 3-jaw chuck, and we can get to turning our sleeve. Before we turn our before we go to turning that bushing, let's step over to the bench and see how we came out. Okay, so as you can see, we cut really nice keyway all the way through the pulley, and you can really tell how poor these were cast. You know, if it was anything else, you'd want to go ahead and square that up a little better, but some of these cast pulleys are really poorly cast. And because our cutter is a true 1/4 inch, you always want to measure these. Just mic them out, but because that's a true 1/4 inch, that's going to be perfect for our key. Good snug fit. Before we wrap this section up, if I were going to have a dedicated tool for broaching keyways on the lathe, what I would do is, this is our cutting surface here. I would go ahead and put a relief here, as well as these two sides. You can see there's a shiny spot right there where it was kind of rubbing. Not a big deal, still had plenty of relief, but the sides of our keyway are also a cutting surface as well, and so it wouldn't hurt if you was going to make a dedicated tool for doing this on the lathe, to go ahead and profile this tool just by cutting a little bit of a relief around those 3 sides, just to help clear chips. Anyway. Okay, so we're back at the lathe. We got our 3-jaw chuck freed up, ready to turn down our bushing. This is the stock that I'll be using for our bushing. It's just some 4140. Really good for making bushings and shafts of high quality. You could also use 10L14, would be another good choice. So what we're going to do is we're going to get this faced off, and then we'll bore it the internal dimension, which is going to be it's going to be 1 inch and 5/10 thousandths. So you want a little bit of tolerance in there. We want that to be a good fit, and then we'll turn it down to our final outer dimension, and then check fit with our pulley. A couple things that we're going to go through real quick is, I'm going to get my lathe set up the way I like it to be, about 97% of the time. Is I like to have my compound offset. 29 degrees. That way it's set up for threading operations and all of that. And then on my tool post, that kind of floats around as needed for the tool that I'm using. I'm going to face this off first, so I want a little bit more of an angle onto it, and that'll be pretty good right there. I'll get into angles and all of those things in a later video. The tool that I'm using is just an insert tool. Carbide inserts, works real good. And so from there, that's kind of my setup for facing. And we'll go ahead and get this faced. And then we're faced off, then we'll so from here we'll go ahead and get our part faced off. We'll chamfer this edge and center drilled for the boring process. Okay, so we're all set up for our facing operation. So let's get to it. You can see we still have a big high spot right up in here, so we'll go ahead. No, I'm not touching that because that is a very sharp edge. So we're going to go ahead and probably take another 30 thou. 30 thousandths. Good deal. That's all set. So now we'll get everything backed out of the way and prep our tailstock for center drilling. Not really worried about a rough finish on this because most of that's going to be bored out anyway. Okay, we got our center drill. All chucked up. And I am going to gear this down just a little bit. So when you center drill, you don't just want to just punch that hole. You want to kind of touch and then back off, and then touch, and then back off. That way it kind of stays in the center. If you don't do it that way, it does wander just a little bit. Like I said, it's not really going to matter in this because we're going to go ahead and bore it out anyway. But what we are going to do is we're going to use our drills and remove a lot of that excess material first. One thing I'll say about center drill is you see the shoulder right here. You really don't want to go any deeper than that shoulder. That's not correct. Center drilling operations, you want to come up to the shoulder or just a little bit in front of it. That's a proper center drill, and that will assure that your drill will have a good initial bite. Or if you're prepping this to turn on centers, you'll have a good shoulder for your live center or dead center to sit in. So we're all set with that. We'll go ahead and start drilling this out. And what I like to do is push my bit pretty close up to the shoulder, and then I'll set my depth, add some oil, and we're going to go about 1.25 inches deep. When you're drilling, you want to watch your chip load coming out of the flutes, and you really want to use a lot of feel. If you start seeing things getting really hot, notice a lot of bad noises or excessive chip load, or you feel a lot of resistance, you want to back out, clean your drill, add some oil. You definitely don't want to see dark chips rolling off your drill bit. Good drill bits are very expensive, and so I just kind of let everything do its job so I don't ruin my bits. You can see right there we're starting to get some pretty heavy chip load, so we'll back that out, clean everything off. One thing that you really need to be aware of when you're machining parts is heat. You do develop a lot of heat, and if you're not paying attention to that and you work too fast and your part gets hot, it either can come out undersized or oversized, depending on whether it's a critical inner or outer dimension. So you don't want to, you want to work fast enough to where you can make money, but slow enough to where you don't have to go back and rework your parts because they got too hot and now they won't fit. That's why I use a lot of oil. We should be getting pretty close. That should be about 1 inch. You can see our chips are starting to bind up, so we'll back out, clean our bit. going to run this in about 1.25 inches. Coming up on that right now. Should be right about there. We'll go ahead and clean the bit off. We'll jump up a couple sizes. So this is about 11/16. This should go right along pretty quick. Take quite a bit to clog those flutes up. Probably do it in one punch. Almost to the end. Right there. When you get, I'm going to go ahead and clean those chips off, but when you get these long chips like that, do not remove those with your hands. Even if you have gloves on, that stuff is like surgical steel. It can cut right through a good pair of gloves pretty quick and take your finger off. The best way to clear chips is turn the machine off, and then you can clean them up if you have to. With the machine running, use a pair of pliers. Those longer chips I like to get right off the bed, right down to the bottom of right down into the chip tray, because you can have a chip pick up one of those long chips and now you've got a whip running around. I think I'm going to go 15/16. And then from there, we'll start the boring operation. Again, add some oil. I got to refill my oil can. She'll growl a little bit till she gets started. Should be just almost bottomed out. You can tell by the feel. There we go. So we'll get everything cleaned out, get these chips cleaned up, and get set up for our boring operation. Okay, one thing I like to do is a quick dirty way to set your tool post up is I have my boring bar installed. Being that our part is faced off, we can just run our part up to our tool holder, or our tool holder up to the part, square that off, and get our tool holder snug down, and then we can set our depth. I do like to use a depth stop or a carriage stop for that, which this is a carriage stop. This is a carriage stop that I made for my lathe. It works good. I should have put a little bit more thought into it, but we'll talk about that at a later time. Okay, so we got the boring bar set up in the lathe. I got my carriage stop set, and we're ready to go. So what I'm going to do is I'm going to make a scratch pass. Then I'm going to take a measurement, and then we'll run our calculations and see how much we have to remove. So we're going to back out, and we'll get a measurement. I need a 3/4 to 1 1/4 inch. Quick measurement. So with all our pre-drilling, that saved us a lot of aggravation. We are at 953 thousandths, so I need to take 47.5 thousandths. So we'll go back to our 0, and we'll do that in 10,000th increments. And when I get to about 30 thousandths, I'm going to go ahead and take another measurement. As you can see, you really only want as much boring bar as you need. That way you're reducing. That way everything stays nice and rigid, and you reduce harmonic vibrations as well as tool flex. We are going to get at 10 thousandths a pass, we will get a little bit of flex, believe it or not. And what we'll do is after 30, we'll take that measurement, and then we'll back that down. And again, just like everything else, the closer we get, we're going to get it right down to about a 1/2 thou or so. As we near the end of it, I'll show you how I like to find our finished dimension. So 10 thousandths, here we go. And I like a nice slow feed rate. That's what's going to reduce vibration and flex in our tool, and really help everything stay spot on. And then I know you probably can't see this part, but what I don't want to do is run my carriage under power feed into the carriage stop. When it gets close, I disengage the carriage feed and do the last little bit by hand. 20 thousandths. $30 thousandths total. I'm just doing 10,000 passes. And then what I'll do is I'll back this out. I'll set it back to my 0, run it back in there without changing the depth of cut, and then we'll take a measurement. And that'll take any flex, that'll take any deviation that we had in the boring process due to flex in our tooling out. You could very easily just ream this out with a 1-inch reamer. That'd be perfectly acceptable in this case, but boring is a lot more precise, and that's really the way I prefer to do it. So again, I go back to my 0, and that'll just it'll remove any variation due to vibration or flex in our tool, and then we'll go ahead and get a measurement. I'll go ahead and go to my 0. Back out. This is one place where I do like to use air just a little bit to just blow all the chips out of there. Go ahead and get our measurement. We're at 978.5. So we've got about 22 thousandths. So what I'm going to do is I'm going to take 15 and then 5, and then we'll take a measurement and we'll see where we're at. So 15 thousandths. That's really the benefit of having those big drills, is you can hog a lot of that material out. Pretty quickly. You don't need to do it that way. You can use a 1/2 inch. And that'll get you just enough pilot to sneak in there with the boring bar and get started. But that much material, you'd be here for quite a while. I'm going to go ahead and take another measurement. This is where I start getting a little bit picky with everything. I'd rather spend a little more time measuring than have to redo this. We're at 989, so we've got 11.5 thou to go. And so that's what we'll do, is we'll start running. I'm going to run about 5.5 thou, and then we'll measure and just start sneaking up on it. And again, for this part, you don't need to be this critical. Because of the keyway, you are afforded a little bit more leeway as far as fit goes in this application, but in the same sense, the better the fit, the better longevity of our parts. I get everything set back to my 0. Get everything cleaned up. Take another measurement. We are at 997. 997 and 5/10,000ths to be exact. So I've got basically about 3/1000ths to take. So I'm gonna get my dial set to 0. And I'm going to take 1 thou twice, and then we'll just really sneak right up in there on our finished inner diameter. And we'll back that out. We'll check our depth or our diameter. Got about 1 thou left to go. All right. See what we got. And we are at, well, we're bouncing right between 1 inch and 1 inch and 5/10,000ths. So I may actually bump this I'll actually go ahead one little light pass. Add a little bit of oil. Okay, so we're on our final pass. Barely took anything at all, which that's what we want. We want a good finished product. And we are at 1 inch and 1 thou, and I think that's going to be a much better fit for what we're doing. I got thinking about that pulley, and I think that's just going to be in my benefit. I'd hate to get out there, drop this off, and have it be so snug that they couldn't get it on there. So now we'll get this cleaned up a little bit, and we'll swap some tools around. So we have our part faced and bored to our final internal dimension. Now we've got to turn down the outside diameter so that it'll fit into our pulley. And so I have that dimension, final dimension wrote down, and what we're going to do is I'm going to take I'm just going to get our part round, trued up, and then we'll measure and see how far we have to go. Still got a little low spot right through here, so we'll go ahead and take another 10 thousandths. So now we can go ahead and take a measurement. And I have got about 18.5 thousandths to go. So what I am going to do is swap out my tools. I don't like the finish I'm getting with that cutter. So what I'll have to do is I'll have to take another scratch pass because I changed cutters, set the 0 on my lathe, take a measurement, and then we can go from there. The good thing is I want to bump the speed up on that a little bit. The good thing is we've got it trued up, so we should be plenty good to go there. You can see that's a much better finish. take a measurement. One 470. I've got 3/1000ths to take. So we are going to slow our feed rate down, and we got the RPMs cranked up just a little bit. And like I said, we've got about 3/1000ths. And I believe we are right on the money. And this should be a really good slip fit, which it is. Not a lot of wiggle room there. It is slightly oversized, so I can turn it down to final dimension. But that's going to be really nice. Nice fit. So now we will get our part so we'll get our part deburred, and what I use for that is I use just a threading insert. All of it. Get our insert turned around so we can deburr the inside. And then, so with our part deburred, one thing that you can do to kind of finish your part is you can take a piece of Scotch-Brite or steel wool. Be careful of your chuck. Just kind of clean it up. And now what we can do is part it off. What I'll do is I'll show you the profile of my parting tool. This is very sharp. I just touch it up on my grinding wheel, but you'll notice I have a little back angle cut in the top. That just really helps it cut pretty good. And again, you want to make sure that your blade is true to your part. There's a bunch of different ways you can do that. You can actually use your face of your chuck to do that, which that's what I'm going to do. And you can, I don't know if you can see or not, but it is out of whack just a little bit. So we'll get our tool post holder resituated so it cuts nice and true. Get everything locked down. I'm going to want to use a lot of oil. I am going to slow the machine down for this. HL, probably to about 325. Usually if you run into trouble parting, it's because your tool isn't either sharp enough, cut the right way, or your tool height is incorrect. There we go. And then what I'll do is we'll clean off the parting tool. Okay, so we'll go ahead and face off our part. Or face off our stock, so it'll be ready the next time I use it. Get it deburred. We can install our bushing. This is a facing operation, so I'm not too worried about keeping it concentric, just as long as it's square. We'll go ahead and get this faced off to final dimension. Which will be, to go look at my notes, 1.168. Well, I'm at 1.230. So we've got 62 thousandths to face off. So I'll go ahead and zero my compound. There's 10. $20. $30. $40. We'll take a measurement. Okay, so we'll take a measurement. And we are at 1.1895. So we got 21.5 thou to go. So I'm going to set the 0. Alright, let's take a measurement. And we are at 1.1680, right on the money. Hopefully you can see that. I'll try to lock it down. Nope, didn't lock it down. But that's right, that's perfect, right where we need to be. So we'll go ahead and get this deburred. We'll do the inside first because that's what we're set up for. Just get our part. And again, you can use your tool, you can use a machinist protractor. We can clean that up carefully with our Scotch-Brite. And let's check our bushing for fit. That is a really nice fit. It's just the right height. You don't want it really sticking above the pulley. It'd be okay if it was a little bit below, but really good job. So next we'll go ahead and get this ready to cut or mill in our slot. Okay, so we're over at the mill. We have our bushing installed. We have it centered. And we're ready to cut our keyway. I'm using a 1/4 inch end mill. I've got this set up very basic, and we'll talk about this all in great detail coming down the pike. But what I'm going to do is I'm going to go ahead and fire up the mill. I'm going to get a little bit of a scratch pass. Just good, clean passes, nice steady feed rate. Okay, here we go, our last 30 thousandths. I think. Feels like we're all the way through. All right, there we go. So this was a very easy setup, and I'll go through all this in a later video, but basically what I did is I set this up on a very narrow V-block so that my height would be the same, clamped my part down, found the edge, and through the use of my DRO, basically I measure here 0, come over here, find this edge, cut that measurement in half. That's the center of my part. Moved everything to center and cut my slot. That's the easiest way to accomplish this without the use of either a horizontal mill or a very expensive indexing head setup and keyway cutters. I do have all that stuff, but I wanted to demonstrate this being done in a very simple fashion. You can also do this on the lathe, but you would have to make a fixture to hold, in this case, the bushing, whatever part you need to cut a keyway in, and your end mill would go in the headstock, and you would use your cross slide to cut your keyway. There's really not much you can do there's not much you can't do on the lathe with a little bit of know-how, but that can sometimes cost you a bunch of time, and I have a mill, so we can just very easily dial this in, and I think this whole process took me maybe 5 minutes to cut that keyway. So let's head over to the bench. All right, so we're back at the bench. Let's go ahead and take a look at our bushing. You can see the way I milled this keyway is I have a keyway in a keyway, and while I was working on this I went ahead and milled the keyway itself, which is right here. And so the way this works is it slips down into our bushing like so. And so we have the key that locks to the pulley, and then the key that locks to the shaft. And that should fit in there fairly snug. You really has to be pretty square to get that to fit. And you can see you do have a little bit of resistance right there to press that in. So that's a really good fit, really good fix. And I think they'll be pretty happy. So all I did different was on most 1/4 inch keyways, the depth of the key slot should be about 142 thousandths. This is 145 thousandths, and I'll just go out tomorrow and fit it on site to the shaft. Just basically, you know, some file work. If they happen to have a grinder handy, that'd be pretty good. But it's a very minimal amount of material removal to get that to work real good. So there you have it. Well, thanks everyone for joining me in the shop with part 2 of our pulley repair. I hope that we can do some more things like this, just little interesting projects that come down the pike like this that can kind of have a little bit of an abstract way to get them fixed economically and quickly. This whole project, had I not videoed it, probably would have taken about 45 minutes to an hour to fix. We got about $20 worth of materials, so about $85 to repair that pulley versus several hundred to replace it. That's the value in knowing some of these quicker ways to get through some of these fixes. And don't worry about mill setup and how I cut the keyway and things like that. We are going to cover all of that stuff in upcoming videos. I'm really going to try to put together a series, if from a beginner's standpoint, from the lathe and the mill and how to get started and how to dial things in and things like that. So don't get too worried about that. It'll come down the road. We got plenty of stuff to do. So again, thanks for watching. If you found value in this video, please don't be afraid to subscribe and ring that little bell for notifications. Thanks all.